So cheers. And welcome to my talk about the pfaff, talk called Still Fuzzing Faster, you fool. So it's obviously a reference to the tool's name, which is Fuzz Faster, you fool. The tool was initially actually called Fuzz Faster, you fuckers, but I decided to make it more like family friendly. So let's get into the meat of the thing. So who am I? Nobody's interested. So, okay, so about web fuzzing in general. I think this tweet kind of, it's kind of a reverse, but it kind of describes the web fuzzing or alike activities pretty well. I won't read it out loud, but you probably had time to look at it already. So web fuzzing is basically fitting different bits of information, some that you might be supposed to use, like for example, numbers, integers from something to something else, and doing that, well, in sequential order or whatever, in order to find something and basically to test all the different inputs. So web fuzzing, what we see here is a HTTP request. The first line there is the resource that we're getting, and the rest of it is basically headers. In some HTTP request verbs, there are also like a actual data payload, but this works for our like demonstration purposes quite well here. So with as an HTTP request, when you browse to a site, this is what your browser is actually sending to the server of that's serving you the website. So what the web fuzzer, where the web fuzzer comes in, is it basically sends tens, hundreds, thousands, or millions requests that are quite similar, but there are like some variation, and it tries to detect the anomalies from the responses it receives from the server. So for the web fuzzer, you could, for example, here the highlighted word fuzz is the kind of a variable that gets replaced with whatever payload you deliver, and pfaff does exactly this multiple times in a second, and tries to filter out the anomalies based on whatever you have set your filters to be. And well, same goes with the matchers. So in this example, the keyword is added to the URL, and that's by no means the only way to do this, or only value you should be trying to fuzz. Other like popular examples is the host header, for example, in order to find different subdomains that would be served by the same web server. Like you would be getting different content from the same server that has like a virtual hosts for different subdomains of your domain. Some of them might be public, as in have DNS records, and some of them might just be internal and like mistakenly left there or something like that. So So about the input content, what would you feed the fuzzer with? You would feed it with, in case of password or credential brute forcing, you would feed it with password lists, user lists, combination of those. If you're fuzzing APIs, you would use known API paths in order to basically, there are multiple things you can do there, but examples would probably be figuring out if there's a publicly used API, like signaling that the web application is having some, as part of the web application, there is some like a sub application that you can use or exploit. Assets and resource, resource discovery, you would basically just feed within common file names and directory paths, admin.php, wp-admin, so on and so forth. And seeing if the web server sends you a response that differs from the others. Or you can have a bunch of valid input data examples and use a mutator to mangle those and resend them in order to find bugs. So the common targets where the fuzz variable should be or is commonly inserted would be, well, of course, get parameters, either parameter names or values, or, well, obviously both as well. Headers, host header, authentication header, yada, yada, yada. Even user agent, which gets shown in some contexts in the admin or log viewing applications, triggering possible excesses, and so on and so forth. Of course, post data, form, JSON, whatever you might feed it with. I realized that I jumped the gun in the beginning there a bit. So I'm actually presenting about pfaff the second time in HelSec right now. The first time was in the very first HelSec meetup. And at that point, pfaff was like 4 or 5 months old project. And it's come a long way since. There's a lot of features, known good use cases, so on. And I'm trying not to present like overlapping content, and I'm somewhat rushing through the basics here. So basically the meat of this talk will be live demos, within which I will explain what each of the demos is actually doing, which command line parameters are getting used and why. So yeah, sorry about that. Let's continue. So what to look for? So we are sending like 2,000 requests per second. The human eye probably wouldn't be able to actually figure out the relevant responses scrolling through the screen. So we need to have something called filters and matchers. So matchers basically mean that something that would be flagged as a potential match by the fuzzer if it meets something. So the matchers and filters are like interoperable. So when I describe something for matcher, it basically applies for the filter in reverse. So matchers would be like you want to match all the HTTP response codes, let's say 200, which is okay, like redirects 300 somethings, but you're not that interested in 404s. So you would add like a few matchers, which would be like the response code 200, 300 to 399, which the pfaff accepts ranges as well as like direct single integers as values there. For the filters, when you run the pfaff for the first time, you like figure out that there's like every third request responds with 200 because of how the web server is configured. So you try to figure out what's the similarities with these within these like basically false positives from your view at that point, and it might be like a response size, where you in which case you could add a response size filter. So on the new run, you would still match with like a 200 responses, but filter out all the responses with a set response size, which is something that you might know is a false positive. The other obvious things besides response codes and response sizes are like a regexes. So you're able to match the content of, well, response headers or response content. So it gives quite a bit of versatility there. So there are a ton of tools that are able to do some of these things, or most of these things, or all of these things. There's Burp, everybody knows and loves. OWASP Zap, quite a big, good project as well. Derby, Dirbuster, wfuzz, which is really, really similar to pfaff, written in Python, good tool as well. GoBuster, and well, pfaff. So there are plenty. Why do we have another one, which is pfaff, obviously here? So as a good like open source citizen, why the hell did you write your like your own when you could have contributed to existing projects? So this is basically the reason. I tried. I asked. I needed a few features. I liked GoBuster at the time. There were like some issues I was facing with other tools as well as GoBuster, and I wanted to fix them. So I asked. I had a few things that I wanted to fix, and asked the maintainer of the GoBuster. They had this huge PR in their GitHub repo that was like 1,000-something lines, touched almost the whole code base. It was a huge refactoring PR that had been open at that point months. So I asked the author if I should base my changes on the master branch or the changed refactoring branch, and their answer was that please don't do anything right now. They are like overwhelmed, cannot review the commits and so on and so forth. So pfaff was born pretty quickly. I don't think it took too long, like a week probably after this, when I had the first like a demo version of for the friends. So let's see pfaff things in action. So about my demo setup there. It's artificial, obviously. I'm running a bunch of different kind of seemingly vulnerable endpoints there on a server. But this is not obviously a real life situation in any sort, in any way, but it helps to demonstrate the different functionalities in pfaff. So let's start we'll start with the super basic stuff and move towards the more advanced or things that people might not grok from the or figure out when seeing the name pfaff or hearing the term with fuzzer. So the first one, obviously, resource discovery. It's so additionally, for all of these, well, most of these demos, I'm using word lists from a GitHub repository called seclists, which is a great collection of different word lists for different purposes. I have all the links on the last slide. I will share for interested parties. So let's get started there. So resource discovery. pfaff is the name of the tool, obviously. -w, which is a word list. So we are defining the word list we want to use, which in this case would be seclists, discovery, web content. We just want to go broad here. Now, if we and then we add the URL that we're trying to we're using that we want to discover content within. So pfaff io.fi fuzz, and fuzz here, that's the keyword that the pfaff is going to replace for each of the requests. So the pfaff will generate a request for each line found in the word list here. And that means 20,000 requests in total. If we want to expand the search there, we can add file extensions like file extension.php, for example. So each of the input lines from the word list will will get retried with the extension .php. Basically, in order to be able to have like a generic word lists and just use web application specific or application technology specific file extensions and so on. And that's it. We add -c, which is colorize output, makes it much more obvious to grok what's going on the first site. And I also always use the verbose option myself. So let's do the content discovery. I wonder if we are able to find anything we should, because I set up this demo for it, but we'll see. Okay, we found a directory. It has an HTTP status 301, which is a redirect, response size of 185, yeah, and so on and so forth. Okay, there are like a few different sets of content there. Yeah. pfaff also has an option to recurse the directory, so I could have added like a recursion here, and the pfaff would have kind of internally restarted itself and started fuzzing the dir1 first, and after the whole like 41,000 words long word list would have been exhausted for the dir1, it would have moved to this other directory pfaff was able to find. And well, until the recursion depth is exhausted, it would basically jump to subdirectories of subdirectories and so on and so forth. It can be like a really long process. Anyway, this is the content discovery. Now we know that there are like a few different pieces of content. This word list is not that great. I know there are like other files there as well. They just weren't included in this word list here. Okay, so the content is basic content is covered. So then the next example would be how to brute force a password. So you have a login form, which my demo environment unfortunately does not have the UI, the actual HTML for the login form, but it does the backend processing. So you're able to see how to actually do the brute forcing, even though you're not able to see the form. Forgive me, I have been lazy. So brute forcing the passwords. The password, the endpoint that we're trying to attack here is, so we're going to send post requests to pfaff.io.fi -php, and we are going to send, it has two form variables, which are username is something, and password is something else. So this is basically the request we're going to send. So just to show you what the request does, I used the curl here. So we sent the request to login.php and got a response, something, and status errored. So there's history why it's errored, but yeah, not. So anyway, we know how a failed login attempt looks like. So we have the errored, which is probably something that we should filter out when we are doing the brute forcing. So let's have a list of users. We have admin, we have root, we have user, we have joohoi. And seclists provides plenty of different password word lists as well. So let's just use one of those. And for the actual ffuf command for the password brute forcing in like a form would be ffuf colorized output post as HTTP request word. Need the content type, application XW form URL encoded. This is because many of the form handlers actually skip the content if this is not defined correctly. And for the post data, we use username is user and password is pass. The user and pass here, the uppercase words are going to act as the keywords for the payload input, basically, like input variables there. And we are going to target our login form, which is at https ffuf.io.fi login.php, and we want to filter out the responses that contain errored. So we add a regex filter that filter us the errored there. Verbose output, and let's see. Error happens. So the error here is, okay, I forgot to find the word lists. So word list first, the first word list would be the users. And by using I can separate the word list from the keyword here, like user. And the second one would be the password word list. Seclists password words. Let's see. Okay, dark web. Let's go with 1,000. It will generate like a 4,000. Okay, let's go with 10,000 one. Yeah, that should not apparently. Okay, so fuzz defined but not found in headers. Okay, I forgot to define the keyword, which would be pass here. So there we go. Okay, so we found our login credential. It was apparently in the very beginning of the password file. There's no reason to go for the full run there. We found it. It's please do not hack me. It's like I use it in multiple places. So that was the basic like form post form brute forcing thing there. So how about the how about brute forcing HTTP basic authentication? So we can do this. Same thing basically than we did in the last command. We have the word lists here. We have the password word list. We have the user name word list. We don't want to filter with errored. The actual endpoint would be, I think it was the here. Yeah. So there we have a basic authentication, which of course returns 401 if the login is unsuccessful or the credentials, it doesn't have the authorization header. So secure, which is the URL we want to break into. We are not going to do post data because that's not how that works. We don't need to set this one. We don't need to set this one. So instead, to inject the username and password combination, we can actually do it here. So user pass at the whatever URL you're targeting, and that should be it. And now, because we didn't set up the correct filtering, we are receiving all the responses. So we want to filter out the 401 responses. And there we have it. Like as I told you, I really use this password everywhere. So yeah. Basic authentication. So other stuff that I briefly talked about was virtual host discovery. So a web server is running multiple sites, and we want to figure out the host names of the sites that basically get served by the same server, but with basically different content. So what we can do is targeting the same server, but fuzzing the host header there. So a common thing that we could do here would be ffuf, polarized output, word list, sec lists, discovery, DNS. There are multiple word lists with different subdomains here as well. So use peers host list. And URL is again our pfaff.io.fi. But let's see, we want to fuzz the header, so we add the uppercase H. Host is fuzz.pfaff.io.fi. We're searching for subdomains for pfaff.io.fi. And yeah. Okay, so we're getting a ton of responses. Everything is basically responding with 200 because the default vhost takes over. And here we could, for example, we could filter with the size. So we see every response comes with size 16. Filter size 16. Now it looks better, but not good enough. So what is wrong with my demo? So we have the host list there. ffuf.disobey.fi. We have the fast. I don't know. No, it can't be this. No. Okay. First broken demo. It should basically detect an anomaly there. I'm not sure. I was fiddling with the demos prior to the talk, so I probably broke something. This is the syntax you should be able to use anyway. So up to next one, which hopefully works. So parameter discovery. So we have a page here which has a pretty common parameter. So we have content.php, and we want to figure out if it has if the script has any get parameters. So first we want to probably do the parameter discovery, which would work in a way like, for example, doing and using word list, sec lists, discovery, web discovery, burp, parameter names. So there's the sec lists already contains a good list of different commonly used parameter names as well. Using that and targeting our URL, which is https ffuf.io.fi-content.php, and we want to fuzz something. So we want to first figure out the parameter name here. So let's see. Okay, well, that was fast. Well, the whole word list was basically gone through pretty quickly. So we have the parameter ID. So what the ID usually does, it takes a numeric value, like ID 1. Okay, so we got some content there. So next, we might want to figure out which IDs can we extract some data out of. So for this, we would do basically the same thing, but just substitute the fuzz. Like now we know that the parameter name is ID, and we can substitute the value with fuzz. But for this one, because we just want to go through a list of integers, probably in sequential order, we don't want to have a kind of word list. So we, as a word list, we use -w-, which means read the word list from a standard input. So here we would do sec, which is a GNU tool that outputs a sequence of numbers. We want to output a sequence of numbers from 1 to 10,000, let's say, and pipe it to pfaff process, which will use that output of sec as the word list. So let's see. Okay, so we need some kind of filtering here again. So let's filter this using the size here. FS12. Okay, a 3 is a proper ID there. Apparently a larger one as well. Okay, so here, it's probably a good idea to demo one of the features here as well, which is outputting the match, like the request and response content for matches, like matches. So we can use -od, which is output directory. We like ID fuzz, let's say, and rerun the command. So for all the matches, a text file will be created here. Here's the file name. So id fuzz, and this file name will show us what exactly what got sent to the server and exactly what was the response. Okay, so pfaff. So yeah, all right, up to next. How much time I have left? Probably some. Okay, few fast ones. So I forgot forgot in the beginning. I was supposed to actually tell you that I'm planning to, because I have the opportunity to actually like share my screen in a good way here, and to be able to basically work from a comfortable position, so I can actually hit the keys, unlike many of the actual situations where being on stage, where you have to crouch or like handle your computer from a weird angle. So I would like to have a lot of questions, and because I have the opportunity to actually answer them and probably and most likely show how something should or could or can be done using pfaff here. So actually walking through the answer in a real sense there as well. Anyway, so post the questions in the Discord, and I'll try to take as many as I can. So a few fast examples before that. So XSS helper. So you found a URL that reflects some kind of user controlled input, and you want to figure out if you're able to leverage it to get an like a get a alert to pop. So you can do this. Well, you can use pfaff to help you out there by using a word list which lists like a special character, so you know basically what kind of filtering are you against to. So we will send all of these different characters. This is like a really fast like a created word list, and it should include like a more complex stuff, not like single characters, but the short clippings of strings and things like that. For example, like as an example, there's a script here. So what we can do here, so we had found a reflect like a endpoint reflecting content at https pfaff.io.fi dash reflection.php. Who would have figured out that it actually reflects something? So data is something, and it reflects the value of the data variable here. So what we can do, colorized verbose, this is our URL, and we want to not to only use fuzz, because we are prone to find in the reflected content of the because it's HTML content, we're going to find the greater than, lesser than characters, like we're prone to find quotes and so on. So we want to add like something around our fuzz value here. So we do ABC like this, and then because we want to figure out what gets filtered out, we're not that interested what gets left in. Well, of course we are, but in order to be able to figure out our restrictions, we need to figure out what gets filtered out. So we want to add here, like we want to filter all the matches that actually contain the ABC fuzz ABC. So this way, all our responses, all our matches that get printed out by pfaff should be characters or strings that are filtered out by something in the web application. And we have an error. And the error is not obvious to me. let's see. It's a good tool, but I cannot use it. Okay, W flag is required. So we're missing the word list. Oh, chars there. Okay, so the word list was pretty small, and it was run in a flicker of eye, whatever. So we were able to figure out that there are like a single quotes at and string script that gets filtered out, and we can use that information to actually build our XSS payload, like actual XSS payload. So this could probably be a good point. This is not the perfect example, of course, but as I said previously, we all love burp suit, and pfaff is able to work or complement the burp suit there, and you're able to for all the matches you find, you're able to send them to or through burp. What makes this feature really powerful is that, at least personally, I usually run pfaff on a remote VPS, and by creating a reverse SSH tunnel, I'm able to open a localhost port, which is running my burp, obviously, to a remote VPS localhost there as well. So I can do things like this, which sends the matches from pfaff to my burp. So we use a command line flag replay proxy, replay-proxy. Okay, and it's our burp running in port 8080, which is here. And when we run this, we should see our matches here in the HTTP history. So that was it, and surely enough, there's our stuff. So from here on, we can send it to repeater, start working with with this like manually. Of course, this was not the perfect example because it was basically just scanning the stuff that gets filtered out, but you still probably get the idea. The other example, which actually I should have used this feature on, is like a scanning for template injections. So here I have a word list that has like a different strings. I could have done the same thing here. I made the demo in a rush. I could have used the same thing here, like just using the word list with the basic template injection payloads here, like these. But anyway, what's important in this demo is that all of the inputs, all the payloads are like calculations that result into same output number, basically, which is 42 in this case. So our example, oh, what the hell? Let's actually use this. So we will use our template injection playlist here, word list here. And we don't want to do that, but instead we actually want to match a regex where the output will be ABC42 ABC, and our demo for the template injection is in the same PHP file, but at different get parameter here. So in the common case, you would have like a bunch of you would have a additional word list for all the URL paths that actually have the have some kind of parameter, and you would be blasting through all of the found get parameters from the web application with these kind of tests. but for the clarity of the example, it's just one here. Okay, so we actually found one. So it's a kind of your classic Jinja template injection here. And now we can see the stuff in burp as well, because I sent it there. So if we add it to repeater, we can see that surely enough, it responded with the result of the calculation within the template injection. And then you can start developing your actual payloads from here. Anyway, that's I'm probably going over time, especially if I want to answer questions. There's a bunch of more examples going through different features of pfaff, and you will be able to see those. So all the different demo content is here in the slides. There's a ton, and there will be, and you will be able to find the slides from this URL, ffuf.io.fi/HelSec. And yeah, here are the URLs. Anyway, thanks.
Thank you very much, Joona. This was a really good presentation, and we will have a few questions from the chat. There was like a lot of them, like fucking lot of them. So you have to answer them afterwards, after this stream ends from your part. But I will go through a few of them. The first and the most important one: what beer are you drinking?
Oh, it's a bulk IPA. I have there like a NE IPA brewed myself, and currently in the fermenter there's a double IPA, and I'm going to brew a new batch in the upcoming weekend.
Sounds really good. Sounds really good. What payloads would you recommend for web fuzzing? Any lists you are using or could recommend?
Yeah, the sec lists I already mentioned. There's also a good collection of different word lists called FuzzDB. It can be found from GitHub as well. There's the legendary all.txt from Jay Haddix. It's a huge huge word list, but you most likely won't need to add runtime file extensions to that one. And you probably shouldn't. Yeah, and of course, you should always generate your own playlists, from the target specific ones, or application specific ones, or context specific ones, language, either programming language or natural language specific ones, and yeah, generate your own ones.
All right, then.
That's all
I think that was a good answer for that. Did you know that the ffuf is the most common browser people use to browse Visma's services?
Yeah. I have the absolute pleasure to know Joachim from Visma, and
this wasn't actually Joachim's question. So.
Oh wow! But yeah, Joachim actually, Joachim is one of the people running the Visma's bug bounty program, and he actually provided me with that data personally. So yeah, it was a quite funny thing.
Yeah. Is there a CMD flag available to resume word list at a specific line number?
Not yet. It's a feature that's in development. So the whole kind of feature that's in development is to be able to write the whole configuration to the output JSON file, which also means being able to resume a run from a output JSON, basically. This has multitude of different options for usage down the road. Things like running the same scan with the same parameters, same word lists, and seeing the differences in the outcome. which would be an obvious one. Other one would be exactly that, pausing the execution and storing the state information within the output JSON file, which would be like a word list position basically. And that way you could resume that run. Other stuff would be doing the exact same command with an additional filter, additional matcher, whatever, like a additional command line parameter, whatever. But yeah, not available at the moment, but in the works.
Alrighty. Does ffuf support fuzzing generators like radams, which could create new inputs during runtime from the base word lists?
So I actually had the slides have slides for these questions. Yeah. So what the fuzz? This is not fuzzing. This is just brute forcing. Bringing the fuzzer, and here's the fuzzer. It uses radamsa as an example here. It has a different slide for pre-generating the mutations, and yeah. Oh, one of the things I actually didn't go through was using an actual raw HTTP request. Sorry, I'm rambling. Next.
All right, but there was actually questions related to this one as well, but I'm not going through them. One of the most important questions is ffuf.io.fi available to play with?
Oh yeah, sure. It has a few static files. There's nothing dynamic, but sure.
Alrighty then. And the last but not the least question, pystyykö vetää?
Kyllä pystyy.
Yeah, this was question from Komblini Kuberg. So
okay.
Yeah. But yeah. Thank you very much, Joona, for your presentation. It was really good. There is a lot of more questions on the Discord. So if you could please go and answer them, it would be valuable for our viewers. But next one is going to be the Hollywood hacker, Laura. Yeah.
The Laura.
Oh my God. Yeah. So a few minute break and we will continue with Laura.
Yeah. Thanks.